Hey, here's a small update. I've got started on the renderer. I've also moved stuff to their own kind of header files because it's going to get kind of unwindy. Alright, here it is. I've implemented the shaders and I've wrapped it. The programming side of things, which handles two different objects, the a vertex array and the program object. Um, I have several methods for helping me with attributes and uniforms, and I got a vertex buffer. In the game, let's see here. I'm just using a test group of shaders, which is this one right here. Come on. Which are pretty basic. In the vertex shader, I'm just simply moving the vertices to clip space, and in the fragment shader, I'm just simply setting all the colors to just a white color. So let's see here. As for the program itself, I have it where the background color is a blue color, and I'm just rendering a 2D suplex, aka a triangle, and here it is. Alright, I'm back again with a small update. I finally implemented index buffering, which is right here. What index buffering allows you to do is to basically optimize vertices. Um, I'll just demonstrate it to you in the game kind of file here. If you go up to here, right, and you have, for this example, you have 4 different vertices, and there's an index for each of them. There's 0 for this one, 1 for this one, 2 for this one, and 3 for this one. When you add them in, you're trying to build up triangles. So 0, we use this vertex. 1, we use this vertex, and 2, we use this vertex. It'll draw a triangle. For this one, 2 is the first vertex, 1 is the next vertex, and 3 is the final vertex that will build up a triangle. So with these coordinates, you can build up a quad with them. This is kind of simple how it works. Kind of similar to buffers, which right here I'm still binding up a buffer to this pointer for vertices and this shader, which I'll show right here, which uses this. But as for indices, instead of binding it for a shader, you're binding it to the draw call, which this one is draw elements. As you bind it, you call draw elements and you pass it kind of the same information that you'll do for draw arrays. Say I want to draw a triangle. Instead of checking for the size of the regular buffer, you're doing it for the indices, which I'm passing it the number of them. They are unsigned ints. And for this last value at 0, it's actually passing indices directly to it. I'm not doing it because I'm using a buffer. So I guess for now, let's run it real quick. I'll move it to the corner. There we go. As you can see, I'm rendering a quad, essentially. Let it spin there for a minute. Okay, I think this is it for this update. Hello again. I just got done adding textures to the game. For right now, it's just simple 2D textures. Sorry, I'm watching a video in the background. It's simple 2D textures. You can load them using a file path, or you can just init a texture that doesn't have anything and push data to it. Let's say procedural generated textures, for example. Um, for binding, you can bind more than one texture using the GL active textures. So let's go to game. Um, I just noticed something. I forgot to add a sampler to here. Let's add that real quick. And because I'm gonna give it a default value, it's the zero texture. So I'm just gonna set the 0. Okay, to fix that problem, I needed an additional texture chord. So let's go to I need texture chords, and I'm gonna pass that to it. So I'll demonstrate what they look like real quick. And I'll move you over here. There we go. And you might be wondering, oh, it's black in this corner, it's red in this corner, yellow in this corner, green in this corner. It has a gradient. This gradient represents the kind of texture chord data that I'm using, which you go down here is 0 to 1 to 1 on the wide, and all both x and y being 1. That's why it's giving you that gradient. These texture chords were basically, if you know how it works, is that a texture chord in OpenGL is from 0 to 1, which basically scales to the texture. So different texture sizes, say the one I'm using, which is my channel logo, is 512 by 512. But what if I had so 0 would be the left corner, or should I say 0 would be left corner of that texture, and if you go and 511 to 511 is going to be the bottom right side of the texture. Just to tell you how it works. It's done this way because each texture has a different size, and it would be a very huge hassle to implement that in the back end. Sorry, I'm yawning. And the drivers would be even more ridiculous than they are right now. You can see here I'm loading up the texture. I am binding it, but I'm just not rendering it. I'm just demonstrating those text chords. So let's render that real quick, which is uncommenting this. As you can see, it's just Mr. Angry face spinning around infinitely in a circle. I think this is it for this update. So I'll see you in the next one. I found something interesting about C++. Let's just say mistakes were made. Yep, mistakes were made. And let me show you what I mean by that. You have a class here, test shader, which is for I'm making a little kind of wrapping system to wrap up shaders and that sort of stuff so I can have a higher level framework that I can play around with. I'm going to also do it with geometry. Well, let's just run it. I'll show you what I mean by mistakes were made. Alright, it built finally. Um, let's just run it. As you can see, it renders nothing. Now let's look at the source code. I went through the source code for a while. I'm comparing it to what is on the GitHub, which is everything's written correctly. You look at the shader code here. As you can see, everything's identical. Everything's identical. However, look at abstract shader and then compare it to test shader. You see something wrong here between these two. Have you noticed yet? Apparently, when you're doing OO and C++, it doesn't take into the account that one class, the parent class, which is abstract shader to this one, has the same parameter names in the I will reframe it. Both of them have the same fields. This one has vertex shader. This one has vertex shader. This one has a fragment shader. This one has a fragment shader. This one has a program. This one has a program. If you start getting what I mean by that, let's run it again. So what it's doing is that in this test shader, it's looking at two sets of fields with the same name. That's why it's not working. So once I delete this, rebuild it. Alright, the build just got done. Now let's run it. You see what I mean? It works now. Gotta love logic errors. Gotta love logic errors. Alright, be back in a bit. Hello again. This will be another update. I just got done with some higher level framework stuff, which is iShaders, iGeometry, and iRender passes. Let's get to the graphics header file here. Well, what each of them does, that's what I'm going to explain real quick. What an iShader does, it wraps shaders and makes them more kind of user friendly for me. This is a basic interface that wraps up this shader object and the program object from the wrapper. It makes it look better, and I can add, and to demonstrate this, I have the test shader down here, which extends this abstract shader, which implements most of these functions. I've wrapped up some specialty vertice pointers and text chord pointer for attributes, and for uniforms I only have the projection matrix, the view matrix, and the model matrix. So it's kind of like a wrapper to make it more document friendly. The next one is iGeometry, which basically wraps up the geometry portion of rendering, which could include meshes, terrain, simple geometric shapes like quads, triangles, what you name it. This will wrap it, so it'll be much more usable. it's a template because I want to certain shaders here to basically use that shaders program. It makes pretty easy to implement. Just an abstract test shader geometry, and this one pretty much makes it where it's a quad. The next one is iRenderPass. RenderPasses allows you to kind of arrange how the renderer works in certain orders. Right now, I only have one render pass, but there's going to be more than one eventually because I might want to do something with UEs, or I want a hub, for example, for the game, which there is definitely going to be a hub. It makes it easier to kind of just split up stuff. Let's say another example would be, what if I want to implement shadow mapping? I'm going to need to have several shaders for that. What if I want to add in post processing? I want to arrange it to where that stuff is taken care of at the end of the rendering pipeline, because a renderer is technically a pipeline of stuff working on stuff in kind of like a pipeline system. If you looked at any documentation of like DirectX or Direct3D 11 or Vulkan or anything like that, they're the whole renderer is split up into a pipeline, and that's what I'm essentially doing here. I guess I'll just demonstrate it real quick. It's still the same kind of angry looking face quad. I'm gonna have something different on the next kind of update, because I'm gonna be the next task is gonna be working with meshes, working on a new mesh format and mesh loading into the game engine. So hope you look forward to that. Okay, and in the game.cpp file, this is kind of how the render pass kind of works. As you can see, the render pass, there is a render pass manager. It's right here in all of its glory from the graphics setup here. Let's see here. And to use it, you basically initialize, set the callback for the main render pass. You pass it all of the render code that you need, and then you add to the render pass manager, and you initialize it, which initializes this internally, and then you render it, and then you release it. You don't have to worry about releasing this one because it does it automatically. So yeah, and this, I kind of forgot to demonstrate this in video for demonstrate this earlier. So I guess this is done with this tiny little update.